presentation. This presentation will be based on how to check the duplicates. So I'll use the same data. What you have to do here is just a simple case. What you have to do is to write here under the command window. Just write duplicate report. Duplicate report, and I've seen it has been reported here that one copy has got duplicate. So here it indicates. Now if you want to find the list of duplicates, what you have to do here, you write duplicate, you just duplicate, but now you just write describe. So on command window, like this, and you press enter. You see, now it is giving me the list of all the duplicates. So now about how to deal with these duplicates, it depends. When they are irrelevant, then you can go back and check here under the data editor and check all the duplicates. If they are relevant, you leave the way they are, or if not, that means you can remove or you can replace with the new information. That is data. So this is how we can deal with the duplicates. So in this presentation, we have looked at how to check for the duplicates and how to deal with the duplicates. Thank you very much. Now it will be over to the next presenter. Thank you. Okay. Once again, I am Van Alfred. I'll be presenting on ordinary least square regression. So on this one, you can use the statistical package, which is STATA, to calculate the relationship between variables, two variables mainly. So in this case, what you have to do is you go, first of all, you have to load the data into the data set of STATA. Then you go to the point where it is written statistics, you click there. Then you scroll, go down where there is a linear model and related. And you go this side to the right and you click linear regression. And here you choose the variables. In my case, I'll just choose education and wage. Is there any relationship between education and wage, or are they correlated? So wage will be my dependent variable. So I'll go here. So I click here to show me where there is wage, then I have to click here, then click OK. Then here, this side I also click say wage versus education, like this. Then I click OK, like this, then OK. Now this is the summary of the relationship. The summary of relationship, you can have an interpretation whereby you have got the R squared values And this one as well, they are showing the relationship between education. So it means that there's a relationship between education and wage. Now our beta one here, our beta one, which is part of education, we have 1.978876. While our beta node, which is the point of interception, we have negative 6.685088. And you have here, you can proceed standard error, t-values, p-values, and the level of confidence, which is 95. So this one, according to the data, an interpretation is, as I said, there is the relationship between wage and education. So thank you very much. That's all what I wanted to present on ordinary least square regression. Thank you very much.
My name is Dick Kapanga. I'm here to present on the interpretation of coefficient. On this firstly, I will start with the definition. To define this, we use an equation which is y is equal to beta naught plus beta 1 x, where y is a dependent variable, or in other ways we can say y is what you are trying to explain. X is an independent variable. In other ways we can say what explains y. Beta naught is an intercept, or beta naught is a value of y when x is equal to 0, while beta 1 is a coefficient, or we can say beta 1 is how much y changes when x increases by 1 unit. So interpreting coefficients is equal to explaining what beta values mean in real life. On point number 2, after giving the definition, on point number 2, we look at basic interpretation or linear model. On this one, I can give you an example of income, where income is equal to 50,000 plus 2,000 times education. To interpret this example, our intercept is 50,000 if education is equal to 0, and income in this case is 50,000. Our coefficient of education is 2,000, for which means for every additional year of education, it has an impact on education. Or to say increases by education, income increases by 2,000 units, holding other factors constant. On another point, point number 3, we look at positive and negative coefficient. We start with positive coefficient. On this one, variables move in the same direction. That is positive coefficient. Variables move in the same direction. For example, education. On education, we can say that more education leads to high income. More education leads to higher education. The more you increase your education, the more you get, you increase your income, which means variables are going in the same direction. In this case, our variable is education and income. Our variables are two, education and income. Let's look at the negative coefficient. This is just the opposite of positive coefficient. In negative coefficient, variables move in opposite direction. A good example is price and demand. As price increases, demand decreases. In this one, our variables are price and demand. As price increase, demand decreases, meaning variables goes in different direction. On point number 4, I want to talk on interpretation in different functional forms. In other ways, on this point, we are going to talk about different models, where we have 4 models. The first one is linear model, which is presented by y is equal to beta naught plus beta 1 x. To interpret this, we see that a 1 unit increase in x has an impact in our y. It changes, it has a unit change in y. That's a linear model. Another one is log linear model. That's our second model, which is presented by in log y equal to beta naught plus beta 1 and beta 1x. To interpret this, we can say a 1 unit increase in x has an impact or brings a change in our y, where our beta 1 is multiplied by 100%. For example, if beta 1 is equal to 0.05, it means that 1 unit increase in x increases y by 5%. Let's see our third model. Our third model is linear log model, which is presented in the form of y equal to beta naught plus beta 1 in log x. To interpret this, we can say a 1% increase in x brings a change in our y, where our beta 1 is divided by 100. I'll take it again. A 1% increase in x brings a change or gives a change in y, where our beta 1 is divided by 100. Our final model is log model. In other ways, we call it elasticity model, which is presented in the form of in log y equal to beta naught plus beta 1 in log x. To interpret this, we say beta 1 is simply equal to elasticity, which means a 1% increase in x leads to beta 1% change in y. a 1% increase